when you're going to use the difference quotient and you're going to evaluate, this is function notation. Notice you have two things that you're plugging in for the x into your f of x function. I would advise you to write this out twice. F of a equals 4a plus 5. F of a plus h equals 4a plus h plus 5. 4a plus 4h plus 5. Now put it into your equation. So f of a plus h is 4a plus 4h plus 5 minus the 4a plus 5 over h. Then distribute. 4a plus 4h plus 5 minus 4a minus 5 over h. Combine like terms. 4h over h equals 4. If you do it step by step, it's not going to be that confusing. Plug in your a into your original function. Plug in the a plus h into the original function, and then rewrite this f of a plus h by what it was equal to, minus, so don't forget to distribute that negative, of your what the f of a equals. Okay? Let's try another one of those. This one is f of x squared minus 3 f of x equals x squared minus 3x. So if I'm looking at my difference quotient, I have f of a plus h minus f of a all divided by h. The f of a plus h, you're going to replace the x with a plus h. Replace the x with a plus h. And now FOIL it. A squared plus 2ah plus h squared. Distribute the negative 3. Notice there's nothing I can combine. Then you're going to do f of a squared minus 3a. Now I'm going to substitute. F of a plus h is a squared plus 2ah plus h squared minus 3a minus 3h minus a squared plus 3a. Distribute that negative over h. A squared minus a squared goes away. 3a minus 3a goes away. 2ah plus h squared minus 3h all over h. Can I simplify that? Greatest common factor. There's an h in all of those. So if I factor out the h, that leaves me 2a plus h minus 3 divided by h. Final answer, 2a plus h minus 3. Do you want to see another example of that one? Determine the domain and the range. The square root of x. What's the domain? Square root of x, graph. What's the domain? Zero to infinity. 0 can be in, so we're going to have the bracket. X squared plus 1. What's the domain? X squared plus 1. What's the domain? X squared graphed is a what? So what's the domain? Here's the graph. What's the domain? That's the range. Negative infinity to infinity or all real numbers. Yeah. The domain are the x values, so it can be anything. The range starts at 1 and goes to infinity. Let's try the next one. X cubed. What's the domain? Yeah, negative infinity to infinity. What's the range? Yeah, negative infinity to infinity. Yeah. Okay. What about x to the 4th? What's the domain? Negative infinity to infinity. What is the range? Here's the graph. 0 to infinity. All right, let's try one of these that have a square root then. This one is 58. The square root of x minus 2 plus 3. I'm looking for both domain and range. That x minus 2 shifted my graph from 0 to the right 2, and the plus 3 shifted it from 0 up to 3. So that point that it starts graphing is at 2, 3. What is the domain? 2 to infinity. Now my question is 2. Is it going to be a bracket or a parenthesis? Bracket. What is the range? And again, can it be bracket or parenthesis? Yeah. If you put a 2 in, you get out a 3. Okay. Determine the domain of a fraction. 3 over x minus 4. What's the domain? Let's look at the graph. So you would be half right. What's the other half? What can it not be? What cannot be in the domain? The 4. X cannot be 4 because you're dividing. So we already know that we're going 4 to infinity. That's the right hand of the graph. What's the left hand of the graph? Negative infinity to 4. Or if you don't want to write it in interval notation, x such that x cannot equal 4. So builder notation. Two x over x minus 2, x plus 3. What can you not divide by? 0. What makes the denominator 0? What makes the denominator 0?
Is it 2 different?
2 and negative 3. So x cannot be 2 and x cannot be a negative 3. X such that. So if I'm going to write that in interval notation, you are going to have 3 parts: negative infinity to negative 3, negative 3 to 2, and 2 to infinity. Are you okay with that?